Good afternoon, class, and we are looking at section 2.1, limits of sequences. In this chapter, chapter 2, limits, we look at limits of sequences, limits of functions at infinity, limits of functions at finite numbers, and limits algebraic method. So first, I would like to remind you of what we saw in 1.6. The definition of a sequence is the list of numbers, where we go with a sub 1, a sub 2, all the way to a sub n, which is the general term. We looked at recursive sequences, such as Fibonacci sequence, where f sub n is f sub n minus 1 plus f sub n minus 2, meaning add the previous two. The first one is 1, the second one is 1. And as of the third one, we start adding the previous two. Arithmetic sequence, we add a constant. So a sub 1 plus d, a sub 1 plus 2d, and therefore, recursively, it's a sub n plus 1 equals a sub n plus d. Explicitly, it's a sub 1 plus n minus 1 times d. Geometric sequence, we multiply by a constant instead of adding like arithmetic sequence. So recursively, a sub n plus 1 is r times a sub n, and explicitly, a sub n is a sub 1 r to the power of n minus 1. The summary of this section, and we will look at them with more details besides the definition of a sequence, which is an ordered list of numbers or function, f whose domain is the set of natural numbers or positive integers. Now, for this section, limit refers to the long-term behavior of a sequence, i.e. what happens to a sub n of a sequence in a long run. So if you look at this one, we write lim stands for limit of a sub n as n approaches infinity equals L. We say that a sub n converges to L when we can pinpoint a limit. But if this limit is equal to infinity or negative infinity or DNE does not exist, we say the sequence diverges. There are limit laws we will look at, but simply put, just plug in the value and observe. I will show you as we come across examples. Let's discuss a few theorems. For example, the limit of r to the power of n as n approaches infinity depends on the value of r. And when r is between -1 and 1 is 0. If it's 1, it's 1. And if it's larger than 1 is infinity. One simple example, if you replace the r, for example, with 1/2, you see that when you square it, becomes smaller. When you cube it, 1/2 becomes even smaller, 1/8, and so forth. On the other hand, if it's 2, when you square it, becomes larger. When you cube it, it's even larger. So 1/2 squared is 1/4, 1/2 cubed is 1/8, 2 squared is 4, 2 cubed is 8. And this refers to this top part where r is between -1 and 1. And this refers to the fact that when r is larger than 1, it tends infinity. And so the limit of 1/n to the power of p as n approaches infinity is 0 as long as p is positive. In short, what it means, if you have a fraction where the top is a fixed number, and it doesn't even have to be 1, any number, it doesn't matter how large it is. When the denominator gets larger, the fraction gets smaller. And when it tends infinity, the fraction goes towards 0. Now, everybody remembers the geometric sequence, and it's a geometric series because we are adding them up. This is the formula. If r is between -1 and 1, according to this, then this goes to 0. As a result of this, this goes to 0. Okay. And we have a/1 minus r. Now, this is the recursive format for a geometric sequence where the solution is b sub 0 or a times r to the power of n. And I mentioned that because sometimes in some texts they use a. And that's a regular basic sequence, geometric sequence we have seen. If we add a constant, and it happens in some instances, for example, when we're dealing with patients and giving a medication at a time step, then this part remains the same and we add this part. And sometimes we use B sub 0, sometimes we use A. And I will show you as we go through some examples later on. As far as the proof, I have it towards the end. You're more than welcome to look it up. We want to see what happens to the sequence. One easy way is just to plug in the first few. For example, for this one, if I put n equals 1, I get 1. If I put 2, 1/2 or 0.5, 3, 1/3, 4, 1/4. If I put 10, is 1/10 or 0.1. And we can easily see that this is approaching 0. So therefore, we claim the limit of 1/n as n approaches infinity is 0. And it's convergent. If we were to graph, it'd look like this. It goes along the x-axis now, of course, the n-axis, and this limit is equal to 0. This is known as a horizontal asymptote when we were dealing with functions. In this case, can anybody tell me what we get when n is 1? What do you get if you replace the n with 1? Anyone? Negative 1 to the power of 1 is negative 1, right? What if I replace it with 2? What is negative 1 squared?
Positive 1.
Beautiful. And what happens is that this oscillates or alternates. 1 gives us negative 1, 2 gives us positive 1, 3. Negative 1 cubed gives us negative again, and 4 gives us positive again. So it alternates between negative 1 and 1, and therefore the limit dne does not exist. B sub n is divergent. So it goes up and down. It alternates. They also say it oscillates. So it is a divergent sequence. All right, let's look at sequential limits. A sequence A sub n has a limit L, and we write the limit of A sub n as n approaches infinity equals L. If we can make A sub n arbitrarily close to L for all n sufficiently large, we also say that A sub n converges to L, if we can do that. Now, this gives rise to what we call limit laws or laws of limits. The limit law says if you have a couple of sequences and both of them are convergent, then the limit of the sum is the sum of their limits. The limit of the difference is the difference of the limits. If you multiply it by constant, you can take it out. The limit of the product is the product of the limits. The limit of the ratio is the ratio of the limits. Of course, the denominator can't be 0. The limit of a constant is constant. We will look at a couple of examples, but like I said, we just plug in and observe. That would be the best course of action. You remember this theorem? The limit of 1 over n to the power of p as n approaches infinity is 0 as long as p is positive. Now, what happens if it's infinity? We write the limit of a sub n as n approaches infinity equals infinity if we can make a sub n arbitrarily large for all n sufficiently large. And it's negative infinity if we can make a sub n arbitrarily negative for all n sufficiently large. Needless to say, these last two cases are examples of divergent sequences. So the sequence diverges in the last two cases. We want to look at a warm-up example, refreshing everybody's memory about one of those theorems, the limit of r to the power of n as n approaches infinity. is 0 when r is between -1 and 1, 1 if r is 1, and infinity if r is positive. So how do we deal with this? We are going to actually use the limit laws. First and foremost, we change this fraction into two fractions. By the way, again, reminding you that you have access to everything, the PowerPoints, except the solution. We're going to go through it step by step, so you don't have to write anything except the solution to the examples. Now, the limit law says I can separate this into two limits. The limit of the difference is the difference of the limits. 2/6 is 1/3. 1/6, by the way, you can think of this as 1 or 1/n. This, everybody, if you replace the 1 to 1/n, makes no difference, and it gives rise to this. And now the limit law says I can cut it into pieces. So we're going to cut this into two pieces. And each one is 0 because look at this one. According to this or this, when r is between 0 and 1 or -1 and 1, this limit is 0. So is this one because 1/3 is in that interval. So is 1/6, this one or that one. And both of them are 0. The result is 0. So we must know basic theorems here. All I want you to do is just plug in. So if I plug in here, so we're going to discuss the first one, limit of 2 to the power of n as n approaches infinity. If I replace the n with infinity, you know 2 to the infinity is infinity because 2 is larger than 1. What about this one? Again, plug in. Now, 2 to the power of minus infinity is 0, and we get 5. So I want to explain why this is 0. I want to remind you of an algebraic technique or formula, if you will, and that is a to the power of minus m is 1/a to the power of m, sum of those exponential rules. If you have a 1/b to the power of, let's say, minus n, you can say it's b to the power of n. In other words, negative exponent, you can move it up and down. And now, if you're looking at this, this is 1/2 to the power of infinity, and therefore it's 0. For part C, simply put, plug in. So you're dealing with a fraction where the numerator is fixed. Again, doesn't even have to be 1. It can be 10,000. It doesn't matter. The denominator is tending infinity. Therefore, 1/infinity is 0, and the answer is 1. What happens when we are dealing with a rational expression and n or x is approaching infinity? So you're dealing with a rational expression. The technique is to divide by highest degree term in the denominator, namely n squared. So we're going to divide everything up here and down here by n squared, or multiply it by 1/n squared. So what do we get? This becomes 2, this becomes 5. This becomes plus 3/n, this becomes minus 1/n. This becomes minus 1/n squared, this becomes 8/n squared. And each and every one of those, with the exception of 2 and 5, 3/n, that means 3/infinity. This goes to 0. Minus 1/n squared, that means minus 1/infinity squared. That goes to 0. This goes to 0. And each and every one of them, this goes to 0, 0, 0. After we apply this, and the answer is 2/5. We have a similar situation. We are dealing with a rational expression. We divide by highest degree term in the denominator, namely n squared. Again, you do use this technique when the variable nx, normally we use the x if you remember in algebra, it's approaching infinity. That's the technique when you're dealing with a rational expression and n is approaching infinity. So you simplify the top, this becomes 3 over n minus 1 over n squared, 7 minus 3 over n. As you can see, n is approaching infinity. That means this goes to 0, this goes to 0, this goes to 0, and this remains as 7. So I would like to see this part and see that the answer is 0 over 7. Why is that important? A fraction is 0 when the top is 0 and the bottom is any number but 0, because if both of them are 0, then we have an indeterminate form. So 0 over 7 is 0. The last one of these, again, we divide by highest degree term in the denominator. All of them are rational expressions, everybody. Rational expressions. We divide by n. So what happens when we do that? This becomes n, this becomes 2, this becomes minus 1 over n. Since n is approaching infinity, this is infinity, but this goes to 0. Now, please understand, infinity divided by 2, infinity times 2, infinity divided by 20 billion makes no difference. It is still infinity. Square root of infinity is infinity. Infinity to the second power is infinity. So you want to be careful with that. But I want to remind you here quickly, and we will discuss that later on. When we did in college algebra, in pre-calculus, when we did asymptotes, vertical asymptotes, the denominator was 0. Horizontal asymptotes, one easy way was to look at the degrees. The degree of the numerator and the denominator are both the same, namely 2, it becomes 2 over 5. The degree of the numerator is 1, less than the degree of the denominator, which is 2, and it becomes 0. Remember, y equals 0 was the horizontal asymptote. Y equals 2/5 was the horizontal asymptote. When the degree of the numerator is larger, we don't have horizontal asymptote. When the difference is precisely 1, we have oblique or slant asymptote. This is just to refresh your memory about what we have seen before. So, in short, all of them are rational expressions. Divide by highest degree term in the denominator, this case n squared, this case n squared, this case n. Calculate the first 8 terms and find the limit. Well, a sub 1 is given, and a sub n plus 1 is 1 minus 1/3 a sub n, which means if I want any term, I'm going to write 1 minus 1/3 of the previous term. So class, can anybody tell me what would be the formula for a sub 2? What would be the formula for a sub 2? Anybody? A sub 2 equals 1 minus 1/3 a sub 1. So replace the a sub 1 with 2. You know 1/3 times 2 is 2/3. And 1 minus 2/3 is 1/3. So we got the second term. Go back to this one. Can anybody give me a sub 3? Because as long as we can get a couple of them, that means we have no problem finding all of them. Can anybody give me the next one? A sub 3. The formula for a sub 3 is a sub 3 is 1 minus 1/3 a sub 2. Now replace the a sub 2 with 1/3. As you can see, their product is 1 over 9. 1 minus 1 over 9 is 8 over 9. Now, we can continue with this, but the problem is we want 8 of them, so that's going to take some time, okay? And that's fine. As long as we can show work for 2, that means we understand it. I want to quickly show you if you are using a graphing calculator for the rest of it, and you can use a simple programming, and that's fine. So in an a sub n, you put a sub 1, whatever the value is, and in this case is 2, store it in x. And then 1, a sub n plus 1 is 1 minus 1/3 a sub n. You put 1 minus 1/3 x into x. And if you enter repeatedly, it gives you this. Let me quickly show you. So according to this, if you look at this last one, there seems to be a sequence converging to 0.75. By the way, if you have any doubts, you can go with a few more and you see that. Worst case scenario, again, you're using a calculator, go 5 more or even 10 more. It clearly becomes that. But I'm going to show you. So 2, you store it in x, it gives you 2. Then 1 minus 1/3 times x, store it in x. If you click on it repeatedly, look at the very first number. Then click it again, look at the next number. Then click it again, the next number, the next number, the next. And this is because you can show work for 2 of them, and the rest of them, when you want to calculate, it does take some time. However, we may be interested in proving this beyond a shadow of a doubt using analytical method, also known as algebraic method. Well, if the limit exists, then the limit of a sub n plus 1 is the limit of a sub n equals L. Why is that? Because as you continue, and you can try this using a calculator, when you get, by the time you get to, I don't know, maybe 15 or 20, then things don't change. So the limit of a sub, let's say 21, is the same as limit of a sub 20. So, but we are, of course, not going with 20. We're going to go with a huge number, a sub n plus 1 versus a sub n. And so we have this formula, and we take a limit of both sides. We have this formula, limit of the left is equal to the limit of the right, right? This is just a formula that is given. And we said this, we say it's L, so is this one, because it doesn't matter at some point how far you go, the limit doesn't change. So this is L, this is 1 minus 1/3 L, and you can move this here, make it plus 1/3 L, and you get 4/3 L equals 1. If you multiply this one by 3/4 and this one by 3/4, then you get L equals 3/4, and I hope everybody knows that 3/4 is the same as 0.75. So again, the purpose of giving you this and the calculator is because calculating 1 or 2 is not a big deal. But since you want 8 of them, it might be tedious, it might take some time, okay? And again, I've proved that. Make sure you pay attention to this if you want to prove this algebraically, you can. Reminding you of the arithmetic and geometric sequence, you remember in the case of arithmetic sequence, we add a constant. So recursively, a sub n plus 1 is a sub n plus d. Explicitly, it's a sub 1 plus n minus 1 times d. Geometric sequence, we multiply it by a fixed ratio called r. Recursively, a sub n plus 1 is r a sub n. Explicitly is a sub 1 r to the power of n minus 1. And it gives rise to, this is called a geometric series because we are adding them up, and it gives this formula. And when r is between -1 and 1, this goes to 0. And it's between -1 and 1, this goes to 0. So a times 1 minus r to the power of n. And remember, a is the first term. So sometimes they may use b sub 0. Again, you're not responsible for the proof. I'm going to quickly remind you how we prove that in algebra. So at this point, here's the series. Okay, we have it here. And so S sub n, the up to the nth term, okay, this is continuous indefinitely, or the following. We're going to add a and a r and ar squared all the way to this number. Now, let's multiply both sides by r. And when we do that, this becomes r times s sub n. This becomes ar squared. And when you go to the end, this becomes ar, and this becomes ar to the power of n minus 1. I hope you see this is a basic algebra. We are multiplying both sides by r. And so if we call this number 1 and we call this number 2, and we subtract in the following manner 1 minus 2, notice what happens, s sub n minus r sub n. Everything cancels out. So this remains, this cancels out this one, this cancels out this one. You go all the way to the end. This cancels out this one. This remains. So we have a minus a r to the power of it. So we can factor out the s sub n on the left side, a on the right side, and if we divide both sides by 1 minus r, we have the proof. Now, so we have this, right? If we have this as the answer, and if we were going to continue indefinitely, then we have the same thing. We have to take a limit as n goes to infinity. So this is summation up to n terms. This is the summation when n goes to infinity. N is limited here. Now, if you take a limit when n goes to infinity and r is between -1 and 1, what happens? This thing goes to 0. And therefore, this will change to a over 1 minus r. We've been through that. I hope everybody is comfortable with that. Let's look at a couple of simple examples. Let's say we want to add 1/2, 1/4, 1/8, and so on. And we notice this is a geometric sequence with the first term being 1/2. But what is the ratio? If you divide this one by this one, you get 1/2. This one by this one, you get 1/2. This one by this one, you get 1/2. So the ratio is 1/2. Both of them, A as well as R. You have to make sure you check. In other words, if you divide 1/4 by 1/2 and you get 1/2, that's not enough. You have to continue and do a few more. So according to this formula, then, the sum is A over 1 minus R. Replace the A with 1/2, replace the R with 1/2. Since this is 1/2, this is 1, and we are done. What about 0.46 bar? What would be the rational number that represents this number? So we've seen this in algebra. There are different ways of approaching it. I want to approach this from the point of view of a geometric sequence now. So I'm going to write this as 0.46, 46, 46, and it continues indefinitely. Now notice this is the sum of 0.46 plus 0.0046 and so on, or you can write them in a fractional format. So let me write that. I want to make sure everybody understands. I could write this as 0.46, 0.0046, and so on. This would be decimal representation. This would be fractional representation. So it's a geometric sequence where the first term is this or that, doesn't matter, fraction or decimal. And I hope you see that this is 100 times this. Therefore, the fraction is getting smaller by a factor of 100. So R is 1 over 100. So we could write, it's a geometric sequence. A is, let me just write this. A is 46 over 100 or 0.46. And R is 1 over 100 or 0.01. You use decimal or fraction, makes no difference. And now this is the formula we're going to use. Replace the A with 46 over 100 and R with 1 over 100. You can stick with the fraction or decimal, makes no difference. This is a complex fraction. You're going to multiply by 100 over 100. And the result is the top is 46. And you multiply this by 1, you get 100. When you multiply it by 1 over 100, you get 1. And so 46 over 99 is the final answer. You should always try to simplify a fraction. It can't be further simplified. We are done. What if we have a mixed number? Well, first understand this means 5.75, 75, 75, and you write it indefinite. So the portion that we are interested in, this is the part that we're going to work just like part B, and we are going to write it in this fashion. So this is a geometric sequence, and we could say, again, I want to make sure we understand that this is zero 0.75, this is 0.0075. So this, you could write it as 0.75, and this, you could write it as 0.01. Let's use this formula, and we plug in for the decimal portion. Again, use fractional format or decimal format, makes no difference. This is a complex fraction. We're going to multiply by 100 over 100 to come up with the answer. When I multiply this by the top, I get 75. When I multiply this by the bottom, I get 100 minus 1, or 75 over 99. This fraction can be simplified because the top and the bottom have a common factor of 3. You can write, this is the answer. In some instances, they may not be happy with that. You may have to multiply this by 33 and add it to 25. If they ask you to put it in a fractional format, no mixed number format. But this is absolutely correct. There is nothing wrong with that. So it makes it 190 over 33. Five times 30 is 165, and add it to 25, you get 190. Not that you have to put it in that format, just whatever they ask you. All right, recursion for medication. First, we remember the basic geometric sequence. B sub n plus 1 is R B sub n. For example, if we have B sub n equals 3 times 2 to the power of n, if I replace the n with 0, I get 3. With 1, I get 3 times 2 equals 6. With 2, I get 4 here, times 3 is 12, and so forth. So this is the sequence we have, and in this format, B sub n plus 1 is R times B sub n. That means 2 times B sub n, where the initial value A or B sub 0 is 3. This is something we've seen, nothing brand new. If we modify this by adding a constant c, this difference equation arises for many real-world examples, such as when a patient is given some medication on a regular basis, and we have b sub n plus 1 is r b sub n plus c. So we just add a constant to that. Now it's important to understand r is the percent of the drug that remains in the body, and c is a constant. This is the portion that remains after a specific time step. Time step is every 10 hours, every 12 hours, every day, every week, medication for pain, medication for diabetes, you name it. By the time we get to the next dose, a percent is gone, and whatever is left in the body is what matters. And C is the fixed amount. Every 12 hours, every day, every week, we give the patient that much medication. So it gives rise to the following formula that I have the proof at the end if anybody is interested, and we are going to explore that by using a few examples. Bear in mind, when it comes to medication and patients, normally this is 0, okay? Unless otherwise mentioned. So first I want to start with this example where it says solve the difference equation b sub n plus 1 is 0.8 b sub n plus 4, where b sub 0 is 5, and we want to find the limiting value. That means we want to find the limit. So anytime you have a question like that, or a word problem, the very first thing is to dissect the problem and write the given. Okay? And remember, we have the formulas, we have the solution, the process. So let's compare this to this. First of all, b sub 0 or a, b sub 0 or a is 5. So we are going to compare this to this. And we are going to write, clearly b sub 0 or a is 5. So that one is given. Now, when I compare this to this, r is 0.8, lowercase c, the constant is 4. Okay. Now we are ready to move on with the solution. So now that I wrote the given, I'm going to plug in into this. I'm going to replace the b0 or a with 5. I'm going to replace the r with 0.8. And I'm going to replace the lowercase c with 4. So this formula results in this. So to simplify this, everyone, we change this to 0.8. And we write this part. Okay, so let's write the first part, 0.8, the power of n. And then the second part, 4, we are going to put this under 4 and make it 4 over 0.2. I thought I put 0.2 here. Times 1 minus 0.8 to the power of n. This part is the same as 4d divided by 2, which makes it tone. Now this part you can treat it as x, if you will. So when we distribute, we get 5x plus 20 minus 20x. Again, let me just write that in case so you can assume this is x. If it makes it easier to see that. Therefore, if I combine this one and this one, I get negative 15x, or negative 15 times 0.8 to the power of n. So you can think of this part as 15x, if it makes it easier to combine them in this fashion. Why did we write it in this form? It makes it easier to take the limit now because we are interested in finding the limit. So the limit of this expression. Since this is 0.8, I hope everybody remembers this will go to 0. This will go to 0. So you get 20 minus 15 times 0. So this changes to 0 because 0.8 is between -1 and 1. And so this goes to 0. And the answer is 20. And if they have given us units, we answer it with proper units. All right, we want to do this. Anybody wants to read this question up to the end of part A for us, please? No one feels like reading?
Well, I guess
Anyone? Go ahead, please.
a patient is injected with a drug every 12 hours. Concentration will be reduced by 90% before each injection, and the new dose increases the concentration by 1.5
Milligrams per milliliter.
milligrams. Yeah. Number A. What is the concentration after 3 dosage?
Perfect. Thank you so much. Anytime you have a word problem, it is extremely important to write the given. Okay. So 12, this is the time step. It's a very important number, extremely important. But it does not get into the formula. Of course, it has been calculated, okay? All the stakeholders, the hospital, the doctors, the nurses, they've gone through the process of calculating that, but it doesn't enter the formula. Now, we are going to write the given before we start. Since we are dealing with the patient, by the way, B sub 0 or A, if you look at part B, it says C sub n plus 1. So we're going to use C. So the very first thing we notice that, so instead of B sub 0, we're going to say C sub 0 or A. It's 0 because we are dealing with patients. Now, we got to give 1.5 milligrams per milliliter of the injection at 12 hours after every 12 hours. So this is the fixed amount. This is the lowercase c. It doesn't change. Now, concentration will be reduced by 90%. Remember, we are interested in what remains in the body. So if it's gone, 10% is left. 1 minus this is left in this question because it says reduced. So C sub 0 or A is 0. Lowercase c is 1.5 milligrams per milliliter. And what remains is 1 minus 0.9 or 0.1. So whatever remains is important. Now, we want to go with the table, and the first dose is 1.5. Now, according to this, 10% remains. So 10% of this remains, which makes it 0.15. And then we add this constant 1.5. So 1.5 plus 0.1 times 1.5 or 0.15 gives us 1.65. What about the next case? 10% of this remains. That means 0.165, and then we add 1.5. So 1.5, and this is 10% of the previous one. Okay, everyone? And that's the table because we were interested in finding 3 of those. So n is 1, 2, 3. Now we want to go with that. First, look at this formula. Everybody look at this formula and change the B to C. So this formula, we're going to change the B to C. Now, all you have to do Whatever you need, get it from the given. I hope you see how important the given is and how easy it makes life. So I need the R is 0.1. I need the lowercase c, it's 1.5. So plug in. And I hope you can see this gives rise to this table. Okay. Now it says find the formula for C7. So I go to this formula, and the very first thing I do, I change the B to C. Look at this formula, everybody. This is what we are looking for. We're going to change it to C. Everything we keep the same, except the B changes to C. And now again, I'm going to go back to the given. See how easy it's going to make it. I'm going to replace the C sub 0 with 0. I'm going to replace the C with 1.5. And both cases, the R with 0.1. So please take a look at the importance of the given. When you write this, it's going to make life easier. Now, clearly, this is 0, so the whole thing goes to 0 here. This is 1 minus 0.1 or 0.9. We can put this underneath 1.5, and that makes it 15 over 9 or 5/3. We do this because we are interested in finding the limit. It makes it easier that way. Now, notice if we try n equals 1, 2, 3, it gives us this table. Let's take a limit. Clearly, this goes to 0 because 0.1 is between -1 and 1, and the answer is 5/3. And now we are going to write the units because the units are given. If not, we don't have to write. The units are given, therefore we give it back with proper units. I want to look at the last question. Could somebody read this last question for us, please? Up to the end of A. Anybody is fine. I appreciate it if anybody reads it for us.
A doctor prescribes a 100 milligram antibiotic tablet to be taken every 8 hours. Just before each tablet is taken, 20% of the drug present in the preceding time step remains in the body. A. How much drug is left after the third tablet?
Perfect. Thank you so much. Okay. So again, we're going to do the same thing. We're going to start with the given. So let's write the given, everybody. Write the given for yourself. See, you can read this. If you can come up with the given, you're in good shape. By the given, I mean B sub 0 or A. And by the way, when you read part B, you see Q instead of B sub 0, everybody. You're going to go with Q sub 0. So Q sub 0 or A, we need that. Or we need that. Lowercase c, we want to write that. So we are dealing with the patient and prescription and medication. Normally this is 0. So instead of B sub 0, we're going to say Q sub 0 or A is 0. Can anybody tell me what is the lowercase c? The lowercase c, the amount of constant that the patient receives? That's 100 milligram of antibiotics. So what is this? This is the time step every 8 hours. Every 8 hours, everybody. That's the time step. So this is the time step. Now, whatever remains in the body is the R, and 20% remains in the body. So pay attention. This question is slightly different than the previous one. The previous one said concentration is reduced by 90%. Now it says 20% remains. So that's the R you want. And so we're going to start with the table. First, after the first dosage, we get the constant of 100. Then 20% of that, which means 20 remains. And then we add 100. So 120. Now, for the next one, 20% of that, which is 24, remains, and we add 100, we get 124. So that's how you get to the table. Now, over here, we go to this formula, everybody, and replace the B with Q. So this formula, we replace the B with Q. Then all you have to do, go to the given and replace the R with 0.2, lowercase c with 100, and you're done for this part. And notice you can calculate the table this way. That's what we've done. We've done exactly 0.2 Q sub n plus 100. That's the meaning of it. So the next one is 20% of the previous one plus 100. What about Q sub n? Take a look at this formula. This formula is about B sub n. So in this formula, anywhere you see B, change it to Q. In this formula, B changes to Q. Again, just use the given and plug in. So Q sub 0, or A, you replace it with 0, or you replace it with 0.2, and lowercase c, you replace it with 100. This given really makes life easy. Needless to say, this is 0 because it's 0 times 0.2 to the power of n. This is 0.8, and we can put it underneath 100. This is the same as 1,000 over 8, makes it 125. And we write it in this format so we'll be ready for the last part, which is the limiting value. Also, I want you to note that if you use n equals 1, 2, 3, you can get the same table. So either this format or this format. Recursively, explicitly, these two are the same. This is recursive solution. This is the explicit solution. Let's take a limit. When we take a limit of this expression, when n goes to infinity, 0.2 is between -1 and 1. This goes to 0. So 125 times 1 minus 0 is 125, and units, milligrams. You use the proper units. Anytime you have a word problem, you answer it with proper units. And that's it, class.